Carbon and its compounds. Introduction. Carbon is the very basic of life. All living things, whether plants or animals and organic matter, contain carbon. Therefore, it is not surprising that carbon is one of the most widely distributed elements on the earth. In fact, after oxygen and hydrogen, it is the third most important element for the existence of life on the earth. The name carbon is derived from the Latin word carbo, that means coal. Occurrence. Carbon occurs in Earth's crust in free as well as in combined state. In the free state, it occurs as coal, diamond and graphite. In the combined state, carbon occurs in solid, liquid and gaseous form. The atmosphere as carbon dioxide, the natural water as dissolved carbon dioxide, natural gas and petroleum, food nutrient like carbohydrate, starch, sugar, and carbonates and bicarbonates such as chalk, limestone, marble, all these are found in the solid state. Although carbon constitutes only 0.03% of the Earth's crust, but it forms large number of compounds. And for the convenience of the study of carbon compounds are classified into two parts, that are organic compounds and inorganic compounds. Organic carbon found in nature through plants and living things, whereas inorganic carbon is the carbon extracted from ores and minerals. Carbon atoms possess a unique property to link themselves together, that is a property of self-linking, to form very long chains of different sizes, which may be straight, branched or cyclic. This property is called catenation. Allotropy in carbon. Allotropy is defined as the phenomenon due to which an element exists in two or more forms in the same physical state with identical chemical properties but with different physical property. Such forms of the elements are known as its allotropic forms, or also called allotropes. In simple way, we can understand that allotropes are what? Different structural forms of the same element in the same physical state. And they have different looks and different physical property due to the difference in the arrangements of the atom. Carbon exists allotropy. The allotropes of carbon are divided mainly in two types, that are crystalline allotropes and amorphous, or you can say non-crystalline allotropes. Here we will discuss about the crystalline allotropes of carbon. Before we discuss this, let's understand what are crystals. A crystal is a homogeneous solid in which the particles like atoms, molecules or ions are arranged in a definite pattern due to which they have a definite geometrical shape with a plane surface. For example, sodium chloride and sugar both are crystalline with a definite cubical shape for their crystal. In this crystalline allotropes of carbon, we will understand the main things like graphite, diamond, graphite. In graphite molecule, each carbon atom is linked with three neighboring carbon atoms and form a flat hexagonal arrangement of atoms. These hexagonal grouping of carbon atoms are arranged as layers piled one on top of the other. The layers are held together by weak forces such that they can slide over one another, and that's why graphite is soft and slippery. Carbon-carbon binding force is strong in the hexagonal graphite crystal, so the melting and boiling points of graphite are high. Pure graphite is prepared artificially by heating powdered coke mixed with a little sand and iron oxide in an electric furnace to a temperature of about 3000 degrees Celsius. There are some properties of graphite. Graphite is a grayish-black opaque substance with a metallic luster. Its density is 2.39 gram per centimeter cube. It is stable to heat and has a very high melting point, around 3700 degrees Celsius. It is soft and greasy to touch. It leaves a black mark on paper. And these are some uses of graphite. Now let's discuss about the diamond. Diamond is perhaps the purest form of carbon. It occurs in all shapes and sizes. Preparation of artificial diamonds. Synthetic or artificial diamonds are made from graphite. Graphite is subjected to very high temperature and pressure in the absence of air. The diamonds product under such conditions are rather small. The value of a diamond as a gem depends upon its weight, the impurity present in it. Colorless transparent diamonds are the costliest because they have negligible impurity. The value of a diamond decreases with an increase in the impurities present in it. A diamond is a giant molecule. The number of valence electrons in a carbon atom is 4. Each carbon atom is linked with 4 neighboring carbon atoms, thus forming a rigid tetrahedral structure. It is this strong bonding that makes diamond the hardest naturally occurring substance. Since they have no free or mobile electron, diamonds do not conduct electricity. The basic tetrahedral unit of a diamond crystal is repeated, forming a 3-dimensional molecule, and the shape of the crystal is octahedral. Now let's understand the difference between graphite and diamond.